Hello, I'm John Roycroft, Principal and Chair of Civil and Structural Engineering at BDP. Welcome to this latest instalment of BDP's podcast series, Old Buildings, New Beginnings. In previous episodes, you've heard from our architectural colleagues as they've discussed the adaptive reuse of heritage, usually listed buildings, exploring the ways we can improve their performance and make them sustainable and accessible. Now we want to bring the debate forward and examine the regeneration of the not-so-old buildings dating from the 50s through to the 70s, which incidentally account for a large proportion of the UK building stock. With their efficient and lean construction, these are the buildings that can prove to be the most difficult to modify, presenting unique challenges but also fantastic opportunities to save carbon. Today I am joined by Victoria Martin, a structural engineer here at BDP, covering BDP South region.
Thanks, John. It's great to be here.
I'm also joined by Chris Goodwin, structural engineer at BDP who covers the North region.
Hi, nice to be here.
And I'm really pleased to welcome George Ballard, building surveyor and structural engineer and chairman from GBG Group, who specialise in structural and geotechnical investigation of buildings.
Thank you very much indeed for the invitation.
Welcome, George, Victoria and Chris. Many thanks for joining us. Over the next hour, the four of us will delve deep into this era of buildings, covering everything from design approach through to creative adaptation of buildings and assets for the 21st century. I would like to start by asking the question, why are certain buildings neglected? We're building swathes of new structures while others lay empty.
Yeah, I think one of the things that's really frustrating, as not just as an engineer and a building designer, but just as a kind of person really, is that I commute into London, and on my journey in, there are these sort of swathes of empty buildings that are sort of sat there, and they're really not that old. And when you look at them, there's nothing materially wrong with them. And yet simultaneously, we're developing, these large new buildings, using up a whole load of resources and materials in the process. And it does raise the question, what's wrong with them? And often, when you speak to clients and building owners, it's actually, it's things that to us might seem quite sort of, I suppose, trivial. It's things like the floor-to-floor heights are often perceived to be, lower than in the buildings that get designed sort of more recently. It's about sometimes they do have inefficient floor plates. I think that's recognised. But I suppose what you have to ask yourself is, at what point does the trade-off between having an existing building with a slightly inefficient floor plate, at what point does building a completely new structure actually, the benefit of that, at what point does that outweigh some of the, I suppose, the sort of the issues associated with the existing building stock? So I think a lot of it is, it's also an issue to do with kind of, everyone likes new and shiny. And it's not perceived as glamorous to sort of occupy these buildings that sit in the middle between the romantic heritage structures and the nice, fresh out of the box, all singing, all dancing new buildings. So they're sort of the unloved, the unloved landscape of most of our cities.
Well, almost it's the unloved heritage. They are indeed. They come from a very specific period of rebirth, regrowth of Europe. And that's one of the reasons for the efficiency of build. People are busy rebuilding Europe at the time. There's very much a model coming from there. And it's now tainted with that image rather than anything particularly wrong with the buildings. They were often put in places where the culture had been damaged anyway. So the images of low-end social housing. And a developer looks at it and sees that and doesn't see a financial opportunity to start work on them. So the most fundamental reason I feel sure that they are ignored is that they are not attractive and not obvious as development objects.
Yeah, I think it's interesting, isn't it? And I don't know what your thoughts are, Chris, obviously from, a different sort of geographical perspective, but I know certainly local to, where we're recording this, we're just up the road from the Barbican, and it wasn't that long ago where the Barbican was sort of seen as this, nobody wanted, why would you have chosen to live in the Barbican? And now it's the height of sort of people are, clamouring to kind of move there, and because they recognise the value and kind of the the thought that went into the design of it. And it does make you wonder how sort of, cyclical this process is. And actually, are the buildings now which are unloved and, people are knocking them down, actually in another kind of 10, 20 years, would they have become the thing that people kind of celebrate for that very reason? I don't know what you think, Chris, sort of with the building stock you're used to.
It's interesting that you say that about the older buildings, because if anything with Manchester, the big thing at the moment is the skyline is just rocketing up absolutely everywhere. So it's kind of interesting that people are going back to big solid blocks almost. So I think the fact that we're almost coming back round to the same thing, which I think is the interesting thing. And I think the stock that's there, obviously, it's not as big a urban sprawl in Manchester and in the north as it is in London, but it's sort of catching up.
I mean, I think there's some perceived risks that we sort of touched on there as well. And I think sort of breaking down the barriers of those perceived risks is important. Certainly the projects that I've worked on, how you integrate 21st century mechanical and electrical systems is a challenge. You really need to understand the buildings and get the best out of them. I think, the next question I'd like to explore with you is, we really can no longer justify unnecessary demolition. In the context of climate emergency, we're acutely aware of our role as structural engineers. So how can we overcome some of these issues?
I think often it's, a lot of this comes down to the quality of the space. And some of these buildings, let's be honest, the era that they're from, if they haven't had good maintenance over the years, that's the kind of the issue really, and why people, don't like them. People sort of think of, the kind of multi-story car park, which is always not exactly the most kind of pleasant place to be. And that it's the buildings of that generation. Actually, if you can kind of plan strategic interventions which allow you to really create a cohesive and sort of communal kind of environment, because a lot of these buildings, they do have, as we've said, inefficient floor plates. They've got, low floor to ceiling heights. Sometimes they can be a little bit oppressive. And actually, if you can open them up and give them the feeling of those, the more modern buildings, that's where I think we can really sort of, add value and bring those buildings back to life and really regenerate not just a building, but the immediate area around it. And you sort of see examples of that, around sort of, King's Cross is a really good example of where a whole area has been, regenerated on the back of actually bringing old buildings back to life. We've recently completed a project at Westminster City Hall, and actually that involved, behind the scenes, it probably looks, to the untrained eye as a bit of a facelift. Actually, behind the scenes, there was a huge exercise to really understand how that structure is working and really sort of identify the opportunities that present themselves either through, where is there latent capacity in the structure? So where can we, perhaps change the way that the load path is flowing through the structure? Where are there elements of the structure that, because of the way it's been constructed, are relatively, are easier in the grand scheme of things to adapt or remove entirely? And as a result, you end up with a sort of a really fantastic 21st century workplace, which is completely, it doesn't look out of kilter against some of its younger neighbours. And the bare bones and the frame of the building is still there. It's just that those really targeted interventions have enabled us to kind of just transform the way it's used and the way people perceive the space.
You're absolutely right. I think your point about kind of improving on an existing building by adding in a new lift core, adding in new stair cores, that's one thing that really does give these buildings a massive facelift, because not only is it sort of the utilitarian on the outside, but you tend to find that on the inside as well. So the stair cores tend to just be top to bottom, and that's pretty much your only option. So by being clever about the way that you put in those interventions, whether it's a new lift core punching up through, whether it's a stair on the outside. I mean, on Merrion House, for instance, we went quite a way to add a stair on the side, a new riser in the middle. They're all fairly simple things, but by working with the existing structure and really getting down to the nitty-gritty and understanding what capacity there is, how you can connect into it, you can really bring these buildings and, like you say, turn them into these fantastic buildings, even if the core of it, the original bit that was there, is kind of underperforming. By just bolting things onto the side, literally and metaphorically, you can really bring them to make really fantastic workspaces and, you know, all those kind of things. It's interesting how just by understanding what you can get away with on an existing frame, you can really bring out the best in it.
And I think that's why it's quite interesting, obviously, having George here as well, because one of the challenges that we often face is, you know, people have gone to great lengths over the years to kind of cover up the structure. You know, for a long time, it's, you know, it wasn't something that was really celebrated.
The idea is to remove the brutalism of the period.
Exactly, yeah. Yes. So people would cover it up, which means that then, in order to really understand how it's working, you either need to go in and sort of, you know, do some sort of strategic bashing about, and we have, you know, sort of people always refer to, you know, you jam the screwdriver into the wall and see where it stops. It's the kind of the very sort of rough approach, but, you know, obviously as much archive information as you can get, and, you know, it's kind of seen as a bit of a rite of passage, actually, of someone sitting there with a microfiche machine and trying to get as much information as they can. But often you don't have that level of detail. And it's great when you've got, you know, nowadays, when we finish a building, we give everyone the drawings in a nice, neat package. You know, back in the day, they would have that set of drawings, but often it's been put in sort of an office somewhere. The places that we find archive drawings are unbelievable. But and sometimes you think we're not going to get anything, and then you go into a cleaner's cupboard and you find there's actually this stack of, you know, original drawings. But sometimes we do need to actually we don't have that information. You have to accept that. And what you don't want to do is make overly conservative assumptions that are going to sort of limit the potential of what you can do. And that's where some of the targeted investigations really come into their own, to try and understand what the building is made from.
And the methods available nowadays to do it without jabbing in a screwdriver, without digging holes, that is a huge boon to this kind of program. The experience gained by investigators of different styles of build, they are often the most useful part to inform the skill, and the previous knowledge of other buildings allows you to build a picture before you get there of what you might expect. And then disproving what you might have expected is the art of the game, not discovery. Yes, there are complex systems. One of the very first ones that I had to look at was Roman Point, which was exactly the kind of brutalist architecture you're talking about. It was a system build, and the key issue on that and many other buildings of the 50s and 60s certainly is the change from master craftsmanship in the pre-war period, where master craftsmen ran the building process, and the clerk of works was going to be an ex-master craftsman of one sort or another. They knew the business, whereas we move in the 50s and 60s to piecework labour and engineers designing things which they are expecting a master craftsman to build, but giving it to basically an untrained labourer to work on an hourly basis. So there's a lot to learn about these buildings, not just from the point of view of what is there and the structural analysis, but what is the characteristic of that building in engineering terms. You know, what did they actually do when they put the design together? So finding the drawings is useful. It's a useful crib. But then discovering how they implemented that drawing, very different.
Thank you. I mean, I think there is a very clear difference between engineers who have experience of building new and those who've come through the system and developed an understanding of how to work with existing buildings. So I think some of the things we've just touched on there are key. At BDP, we have a real skill in unlocking buildings, and when architects come up with ideas, and they want to remove columns or take large floor plates out, then we will spend the time, invest the time, really understand the building, the structure, sweat the asset. And I think that's what we need to see more of. And university education doesn't cover this area particularly well. And I think, as we move forward, we need to sort of push that side of things and make sure that as an industry we can respond positively. I'd just like to touch on how refurbishing a building of this era differs from, for example, before the 19th century. What are the things that really differentiate our approach?
It's interesting, having worked on both historic buildings, pre-1900s, and also worked on more recent ones like the ones we're talking about. You often go into it with, for a historic building, very little in the way of paper evidence of what you've got to deal with. Even up until the 30s, I've worked on buildings where you don't really get a lot in terms of drawings. You may get some architectural drawings that show you a layout, but that's pretty much it. So when you're talking about these kinds of buildings, the records tend to be a lot more thorough, even though you might not get absolutely everything you need. Say, for instance, on University of Warwick at the moment, we're doing quite a big project there to refurbish all of the existing 60s blocks, because the university moved there in the 60s, so all of the buildings are 60s in Coventry. And whilst we've got quite thorough records for most of the buildings, they are just structural GAs, so they give us quite a good indication of what's there, but it doesn't tell us absolutely everything. But as a starting point, that's much better than what you'd get most of the time with a very historic building where you don't even have that to begin with.
Yeah, I think foundations is a really interesting point, actually, because often if you do find that you need to perhaps strengthen some of the superstructure, the opportunities to do that they're not necessarily easy, but they are more straightforward than if you find that actually you've got a limitation with the foundations. But traditionally, people would sort of say, well, 10%, that's, if you go above more than 10%, then you're on slightly kind of shaky ground. But actually, more and more when you sort of speak to people, the line of thought, particularly depending on ground conditions you've got, is that in some cases, particularly in sort of the London area, perhaps you've had a lot of the consolidation that the soil would normally go through when it's loaded may have already happened. And so actually, you can get more capacity out of the existing foundations than, historically, even, and I say historically, I'm talking about, 10, 15 years ago, people would have limited it to. So I think that actually, it's a lot of the time, it's just about actually looking at the building holistically. And one of the things we've been able to do, and we've had success with a number of projects, is sort of producing heat maps to really understand which parts of the structure are working the hardest and which, we all know, as George, as you've said, this was an era when standardization really kind of came into the fore. And as a result, you find that often there is a lot of uniformity. And that means that in some areas of the building, the structure will be working at or near capacity. But you may find that in others, they've used exactly the same element, but it's oversized for what it needed to do. And so by understanding which parts of the structure and particularly if you can kind of communicate this graphically and visually, it very quickly allows the entire design team to properly understand where, if we are going to target interventions, where should we do it? And that's the kind of exercise that is so important right at the early stages of a project. And I can't stress that enough. By having those discussions with everyone around the table right at the beginning, you can make sure you're heading in the right direction and get the highest chance of achieving a really successful project outcome.
We do see a lot of schemes where designs have been moved forward with lots of new piles, lots of new foundations in existing buildings. And I think working with George and the team, we can unlock in quite a lot of those cases significant sort of efficiencies that perhaps as an industry, I think we sometimes sort of look at risk and then we sort of design out risk in a rather clumsy way. So I'd be interested to hear. It
is indeed. Victoria touched on the basic problem, which is the soil that has been loaded for some time, and it's been point loaded effectively, will have probably consolidated, particularly if we're working in any of the adhesive clays, London particularly. And when it comes to analysing how that is going to perform, then it's very difficult to get information from underneath the foundation. You have to use the material around it, which is, of course, what hasn't been loaded. And then you have to fit that information to normal risk pattern that an engineer is looking for. That's particularly difficult because although it's a poorly understood part of geotechnics, that there is a lot of black art to it, where you do approximate, and then because you approximate, you therefore have to give enormous factors of safety just in case. When engineers see the geotechnical engineers doing exactly the same and just simply guessing the level of over-consolidation that has occurred, I can understand their worry. And I don't say that it's necessarily clumsy. It is just a difficulty that one has to overcome. But yes, I think the answer is, in order to stick to Eurocode, it has been frequently necessary to over-engineer the foundations on a reconstruction or refurbishment.
I think that's where, we engineers are educated in first principles, then we come into practice and we often use codes of practice, or and I think we need to, as an industry, look to sort of use the codes of practice but not be defined by them. And I think that's where, as a company and as a profession, we're really trying to unlock assets and buildings. And I think it's foundations. Often it's not about strength; it's about movement and settlement. Yeah, and sort of educating clients around those sorts of issues and parameters, I think, is important.
I think one of the benefits we've got, especially, and I appreciate this does apply, in the first instance to the London area, but also, it is starting to broaden out beyond that. But one of the things that we do have is that now, this is the era of data, and now so many, because there is so much development going on in the London area, and particularly with projects like Crossrail, we actually have a huge amount of data about how sort of the ground beneath London performs. There are a lot of buildings which get monitored as either new buildings, new stories are added, holes are dug underneath them, new basements, and actually I think the industry is much better now at sharing and those kind of lessons learned. And actually it means that collectively there is a huge amount of information which, when you put it all together, gives you a really good, it helps just build that understanding. It's not just about one group of people and what they know about the particular soil. Of course, there you have to be careful. There is always the anomaly. But I think our understanding of how buildings behave, both, at a foundation level, but also, different materials under increased loading, changed load paths, I think our understanding of that is much better. And I think that's something that, is only hopefully going to, increase positively in the future. And
there's another side to it as well. The earliest example of calculated risk on foundations I know of is Sir Christopher Wren on Paul's Cathedral. And he calculated that the ground, I can't remember the exact figures, but it was about 1'9". He expected the great piers holding up the dome and the drum, the great piers which carry that load down to ground through a brick raft, through into a lime concrete, through into brash, right down at the bottom, deep inside the foundations. About 1'9" was what he calculated. In fact, they sank by 22 inches in 150 years. I'm not sure how much more since then, but they're pretty well stable now. And he built in a beautifully engineered solution to the fact that he predicted that amount of foundation settlement sitting inside the cruciform of the church, which of course didn't carry the same load and therefore would otherwise have been rather destroyed by such action. That is perhaps another approach that engineering needs to take, is to accommodate the risk.
I think what's interesting actually, and through the course of the kind of conversation, so much of the things that we've been talking about, it comes back to this kind of two strands. One is the kind of the reason why most of us do this job, because we're curious people, and I say that as in the kind of outwardly curious. we like finding out how things work. Some of us are curious as well, but we want to kind of really, we look at things, we want to understand how is that working. We like problem solving, and I think what existing buildings offer is that opportunity. New build is great, and you can do some fantastic things, but when you're presented with a really tricky puzzle, and the sense of satisfaction you get when you collectively, work with a group of people to come up with something that's very sensitive, is lean, but also transformative. It's so important. But I think the ability to do that can only be done. It is down to the way you think, and it's not something that you can get from books, from codes, from analysis software. They're all tools, and they will help you do it. But fundamentally, it's about that basic first principles engineering approach, and actually looking at the building. Can we remove things which are heavier and replace them with lighter stories? Where does the building, just from what we know about that type of structure and our professional experience, where do we suspect that there are possibly existing kind of defects that maybe need to be resolved? Where are there likely to be opportunities? And it's that real sort of fundamental, it comes back to the kind of vocational aspect. And actually, a little bit what you were talking about earlier with the kind of master sort of craftsman. It's actually going back to the art of engineering and really getting into the kind of the crux of how does it work at a basic level.
I think we're pushing against an open door now. I guess historically, when I started out in the industry, there was a perception of risk, and contractors and constructors may not have wanted to sort of, or certainly would have priced it higher to adapt some of these buildings. But I think now, we're all acutely aware of the climate emergency. There feels a sort of movement of clients, constructors and engineers, who want to make a difference, want to sweat the asset, want to retain material rather than demolish it and lose it. So I think it's a very exciting time. I think as a company, we recognise that fees are tight, but we still invest our time into trying to unlock the buildings. And I think there's a call to arms there really for engineers to put the effort into to really look at low paths, to try and understand buildings, not just to sort of design risk out. And I think the profession as a whole is very receptive to that, but it's something we must continue. But
you balance that. There are two sides to it. One is, you said, fees are tight.
Yeah.
Unfortunately, the more you plan it, the better you plan it, the more likely you are not to encounter the risks that you're trying to avoid. Therefore, you have to balance that. Secondly, of course, then once we're in the business of designing, and when we get to build, along comes value engineering, which can then drive a hole straight through it and take the risk factor right back to the bone again.
Yeah, it's interesting because part of our approach seems to be that we will often look at schemes. And actually, the value engineering aspect of that is where we do unlock the building itself. So we're seeing quite a lot of evidence of risk, embedded in an approach to sort of develop a asset, and then our sort of second opinion or VE sort of interaction unlocks it. So I think there's two angles to that, and I understand what you're saying.
Well, the danger is that you do that, and you ask for a bit of extra fee to do it. Then you get down to the build, and somebody is then asked to value engineer that.
Yeah, it's interesting. I think we are establishing there are significant cost savings in going down this route. I think if it's about targeted interaction, it's about understanding the building. There's a weight of different things. How much information do we have? How much is it a building that's in use? Do we need to ask the client, can they vacate certain areas? Every situation's different, but you sort of judge it on its merit, I guess. I think one of the questions I would like just to open up as we draw towards the end of this is really lifespan of structure. So when we start a new building, we'd set the design life, and it may be 60 years, 75, whatever the client wants. How do we give the client confidence in breathing new life into these?
The first, things? I think, most urgent problem is to define what we mean by design life. To me, there are two elements. One is service life, and the other is potential design life. And service life is sort of easily described as the maximum time you expect the building to go without a serious remedial intervention. And the second is the design life, what you will get out of it if you do carry through the maintenance and remediation to achieve a renewal of service life at a particular period. I think that is really the basis of how you can start such a discussion.
It's such an important point, I think, and it's one that I think, rightly so, a lot of, building owners, clients, and actually other people within the design team sometimes grapple with, because a building that is well designed and well maintained, it's not suddenly going to hit 60 years old and sort of disintegrate into a pile of rubble. And I think trying to kind of communicate that in a way that sort of people will understand, what does, when we're talking about design life, what difference does it make? If we were designing something now for 60 years or 120 years, what difference would that have on what we would do? Effectively, it's exactly say it's about kind of maintenance. And sometimes you will see structures that have been designed for a 60-year design life or 50 years, depending on which codes you're using, and actually they haven't been properly maintained. They've been neglected, and actually they are at risk of failure prematurely.
You started this conversation actually on that very subject, the wastelands around London on unoccupied, unloved buildings. And those are the ones that have had the least maintenance. That's where they look unloved. Because ultimately, a design life, a service life should include the maintenance scheme. Because if you don't, leaving a building out in the rain is one of the worst things you can do.
So I'd like to sort of try and bring this to a close. And I think if you could give some advice to our listeners on what's a piece of advice we can each give from our own perspectives on how to sort of bring the best out of these buildings, from the 50s, 60s, 70s. What is your unique position on that?
I think the key thing you've got to look at what are the opportunities. I think so often when we look at existing buildings, existing structures, existing anything, often all we see is constraints. But actually, you've got to look at what opportunities is the building giving you, and actually how can you turn some of those constraints into opportunities. Maybe actually addressing them is the thing that unlocks the potential of the building, the site, whatever it is. So I think for me, it's just about try and sort of leave a lot of the kind of the baggage, from other projects behind, but bring the knowledge that actually helps you really unlock the key to that scheme.
So don't give up, I think, is what you're saying.
Perseverance. There we go.
Perseverance. And for instance, we've mentioned low ceiling heights so often. Oh no, there's nothing wrong with a low ceiling. High ceilings are the refurbs we've been doing recently, and that's the Victorian to Edwardian period. I live in a little cottage. There are lots of little cottages scattered around England. The ceiling heights below 2.3 metres. And they feel tight. They feel cosy. There's nothing wrong with them. They're just not Edwardian.
I think I'll go for the carbon agenda, because really these are such assets just in terms of carbon alone. There is so much material and so much opportunity there that can be saved by utilising those buildings. Knocking them down just seems a crying shame when it's there to be utilised, and it's our gain to use these buildings. So we should absolutely make the most of them, really push them to their limits, and make sure that we keep those assets instead of demolishing them and making a brand new thing that's going to just sink away carbon.
Thank you, Chris. I think that's a great message to end on, because clearly we need to make a difference as engineers, and reusing, circular economy, all those messages is just so important. So thank you everyone for your contribution, and thank you again.